Now friends, we take some of the conceptual problem based on geometry in a fast forward manner. See, the area of two similar triangles is 9:16, the ratio of their corresponding sides. If the two triangles are similar, their areas are in the ratio of square of the sides. So the ratio of areas is given, that means side must be in their square root proportion. So it must be 3/4, right? Now similarly, ABCDF two triangles, the sides are maintaining this ratio. Here it is not given that the triangles are similar, but AB by DE, BC by EF, CA by FD, all of them are having the same ratio as 2/5. That means the triangles are similar, right? Now if the triangles are similar, area of them will be in proportion to square of their sides. So it's 4/25, right? Just be careful that it's already not given that the triangles are similar. That conclusion you have to draw from this expression that the sides are in proportion. Okay. Now here in this case, ABC is similar to DBC, then AB into DB is what? Now if ABC is similar to DBC, that means the sides will be in proportion. So first of all, we have to find out which angles are equal. See, this angle will be equal to this angle because they are in common segment, right? That is BC. Okay. Now, since AC is diameter, O is the center, AC is diameter, that means this angle is 90 degree in this case in triangle ABC, and in triangle DCB this angle is 90 degree, right? So these two angles are same and two angles are equal to 90 degree. That means they are in proportion, they are similar triangles, so their sides will be in proportion, right? So angle, the side opposite to this is BC, side opposite to this is BC, side opposite to 90 degree angle in this triangle is AC, and side opposite to 90 degree in this triangle, that is BD, is equal to the third side apart from AC and BC, it's that AB in this triangle, and in this triangle it is BD, BC and DC. Right? So we are asked about AB into DB. So AB into DB is AC into DC. As simple as that. Okay? You need to know how to compare the sides when the two triangles are similar. You just have to take the sides opposite to the same angles. I hope you are clear. Now in this question, ABC is such that AB3, BC2, CA 2.5 and DEF is similar to ABC, then EF is 4, then perimeter of DEF is. See, if two triangles are similar, their perimeters are also in the same proportion as the sides. Now ABC, DEF is similar to ABC, that means EF and BC will be in proportion. So EF is 4, BC is 2, that means the ratio of BC is to EF is 1:2, right? So same will be the ratio of perimeter of ABC and DEF, right? So ABC, the perimeter is 3 plus 2, 5 and 2.5, that is 7.5. So perimeter of ABC will be double of that, that is 15, okay? Whatever is the ratio BC and EF is maintaining, the same ratio their perimeters will maintain, or the respective triangles perimeters will maintain. Okay, so that's 15. I hope you are clear. Sometimes it is the fourth option is given as the data insufficient. So good number of students get confused because we are not given the other two lengths. So it is practically difficult to find out the perimeter of this triangle ABC until you know this concept that the perimeter will maintain the same ratio as the sides are maintaining, right? So be very clear about it. Now, in an isosceles triangle ABC, AC is equal to BC. AC is equal to BC. That means this angle will be equal to this angle. BAC is bisected by AD where D lies on BC. That means this angle is equal to this angle. It is found that AD is equal to AB. AD is equal to AB. And we have to find out ACB, that is this angle. A very simple problem, friends. See, already this angle is equal to this angle. Suppose this is x, then this will also be x. Now x that means this portion will be x by 2. Now since AD is equal to AB, if this is x, this will also be x. So x plus x by 2 is 180. So 5x by 2 is 180. That means x is 72 degree. That means this angle is 72 degree. I assume this to be something else. This angle is 72 degree and this is 72. This will also be 72 because these two angles are same. So 72 plus 72 is 144. So in this triangle ACB, 144 if we deduct from 180 will be getting the value of this y. So out of 180, 144 if we deduct will be getting 36 degree. Right? I hope you are clear. A very simple concept of angle sum property of triangle has been used over here. Now in rhombus ABCD, AB square plus BC square plus CD square plus DA square, we have to find out. See, if it is a rhombus, all the four sides of it will be equal, right? So what we can do is we can assume some of the data because finally these are variables. So if for any one value, if the relationship is satisfied, then it will be satisfied for every value, right? So to make it simple, what I do is I assume the length of BD as maybe 8. In short, I take this ODA as a right angle triangle because the diagonals of rhombus bisect each other at 90 degree. So I take this as say 4, this as 3, that means this must be 5, right? Now obviously AB, BC, CD and DA, all of them will be same. AB square, that is 25, 25, 25, 25. This must be 100. Now we have to see from the options where we are getting 100, right? So suppose I take this AC square plus BD square. AC is this complete length, so it must be 6. So 6 square, that is 36, plus 8 square, that is 64. So 36 plus 64, we are clearly getting 100. So this must be true, right? And as I have already told you that if it is satisfied for one set of value, for the remaining set of values also it would be satisfied. Precisely it will become a formula, right? I hope you are clear. Now we have this problem. The altitude drawn to the base of an isosceles triangle is of length 8 centimeter and the perimeter is 32. The area of the triangle is, this is 8. We have to find out the area of this triangle. Now how do we do that since we don't know the other sides? Right, now the basic property of isosceles triangle we need to use over here. See, this length is equal to this length and this is the common side and this is the midpoint, obviously, because if we draw the altitude on the base of an isosceles triangle, it bisects the base. That means this triangle is congruent to this triangle, right? Now this length plus this length plus this length is 32. That means this length plus this length must be 16 and this length plus this length must be 16, right? So this plus this is 16, right? Half from this place to this place, it is 16. Now we'll be using here the concept, the Pythagoras theorem over here. So this plus this is 16. Now you need to recall Pythagorean triplet, right? 3, 4, 5, then 6, 8, 10. So 8 we are having over here and then these two should be 16. So I can take 6 this and 10 this, right? So 8, 6 and 10, right? Now if it is 6, it has to be 6. Obviously because this is the midpoint. Now easily we can find out the area, that is half base into altitude. So base is 12, altitude is 8, half of altitude is 4. So 4 into 12, the area will be 48. As simple as that, right? I hope you are clear. No need to go for much paperwork. Now in this question, in a triangle ABC and DEF, angle A is equal to angle E, that's 40 degree, and AB is to ED is AC is to EF, and angle F 65 degree. Angle B we have to find out. Now angle A is equal to angle E, so I suppose this is ABC and this is DEF. Now these two angles are of 40 degree. Okay. Now AB by ED is equal to AC by EF, right? That means the two triangles are similar to each other. Now angle F is 65 degree. If it is 65, it has to be 65. That means the third angle should be 180 minus all this thing. So this plus this is 105 degrees. So 180 minus 105, this angle must be 75 degree. Okay, I hope you are clear. It's just matter of 30 to 40 seconds. Now, in an isosceles triangle, the equal sides are 7 units each and the length of the base is an integer. From these triangles with the greatest perimeter is selected, its perimeter is. See the perimeter minimum, it must be 14 and then plus x, right? So this x is the length of the base that we have to find out. Now, you must be knowing the triangular inequality. That means sum of two sides must be greater than the third side, right? So sum of two sides over here is 14. So it must be greater than the third side, that is the base, right? So and since base is an integer, so at most it can be 13, right? At most it can be 13. So the perimeter at most is possible is 14 plus 13, 27, right? A very simple concept of triangular inequality, that is sum of two sides must be greater than the third side, is used over here. I hope you are clear. Now in triangle ABC, right angle at C. So this is A, C and this is B, right angle at C, and AD is median. I draw the median over here. Okay, so this is what D. We have to find out AB square in terms of this AC, AD and whatever, right? Now friends, to make the problem simpler, what we can do, we can assume the value of AB, AC and BC because the answer is in variable mode. So if we take a fixed value for any one value, if it is satisfied, it will be satisfied for other values as well, right? So what we can do, we can take a Pythagorean triplet over here. So this must be 6, this must be 8, so it is 4, and this must be 10, right? Now it is 6, 8, 10 Pythagorean triplet. Now fill up the value. AB square according to us it is 100. Now from which relation we get AB as 10, that we have to see AC square minus AD square. Now AD we have to find out. AD will be 36 plus 16. So 36 plus 16 is 52. So this AD will be root 52, right? Now AC square minus AD square. AC square is 36 minus 52. That's not possible. Even it is not possible. 3 AC square, that is 3 into 36, 108 minus 4 AD square. So that is 4 into 52. So the calculation will be negative. Here it is 4 AD square minus 3 AC square, that is 4 into 52 minus 108. So 4 into 52, 52 into 2 is 104, that is it is 208 minus 108, that's 100 that we want. So this is the correct choice. Simply you can do the problem in 40 to 50 seconds if you put up the values to this variables, right? AB, AC and BC we took as Pythagorean triplet, then it is very simple to solve this problem. Okay. Now this problem, a vertical stick of 20 meter length cast a shadow, a 10 meter long shadow on the ground. At the same time, a tower casts a shadow of 50 meter length on the ground. The height of the tower is. Just draw the diagram, a rough diagram. See here, I assume this to be tower. The tower is, we have to find out the height of the tower. The stick is of 20 meter length and the length of the shadow is 10, and at the same time a tower casts a shadow of 50 meters. So this entire length is 50 meters. So this must be 40, right? We have to find out h. Obviously this triangle is similar to this triangle. These two are corresponding angles which are equal, and this is the common angle. So that means this small triangle is similar to the big triangle, right? That means their sides ratio will also be same, right? So in this case this side is 10 and this is 50. So precisely 20 by 10 is equal to this h by 50, right? So h has to be 100. That means height of the tower must be 100. I hope you are clear. Now this problem here, AP is to AB is 2 is to 3. PO is parallel to BC and extended to Q, so that CQ is parallel to BA. Area of APO and ABC. APO and ABC. Pretty simple. This line is parallel to this line and this angle is common. That means triangle APO and ABC is similar to each other. So their areas will be in proportion to square of their sides. So square of this side, that is suppose we assume this side to be 2x, then area will be 4x square, and this side is 5x, so area will be 25x square. So the ratio is 4 is to 25, as simple as that. Okay. Now let's see this problem. Nice one. The legs of right angle triangle are 8, 15. The radius of circle inscribed in the triangle is that we have to find out. So it is 8, it's 15. That means it is 17, being Pythagorean triplet. Now since, just listen to me carefully. See here, I have made 3 triangles over here. See this, this and this, right? Now in all the 3 cases, the base is different but altitude is same. That is the radius of the circle, right? That means area of this complete triangle will be distributed in the ratio 15 is to 8 is to 17, because altitude is same, that is radius. Now what is the area of this triangle? That is half of 15 into 8, that's 60. That is the area of this triangle. Out of that 60, the ratio among these 3 is 15 is to 8 is to 17, that is 15 plus 8, 23 plus 17, that's 40. So 8 by 40 is the area of this triangle, right? So 8 by 40 of 60 is area of this triangle, and area of this triangle is what? Half base into altitude. Okay, so very simply you can do it. So R must be 3. Just in a single step you can solve the problem. I hope you are clear.